Hi everyone, thank you for joining. My talk today is on MLOps at scale. Before we dive into MLOps, let me quickly introduce myself. I've been in the data analytics and machine learning space for over 15 years, building large scale platforms, predictive models, and intelligent systems across industries. Over the years, I've seen data evolve from simple dashboard to mission critical AI systems that influence billions of decisions every single day. In my career, I have led teams that designed end to end ML pipelines, architected the petabyte scale data warehouse, and deployed models powering finance, HR, and other use cases. And more recently, my focus has expanded to world of agentic AI, building autonomous AI agents that don't just predict but can act, collaborate, and make decisions with other systems. Across all of this, one lesson that has stayed constant is building a model is easy, but operationalizing it at scale is the real challenge. That's why MLOps and now MLOps and agentic AI ops are so critical. They ensure models are reliable, auditable, and scalable, turning experimental prototypes into real business solutions. That's why I'm passionate about MLOps. This is the foundation that allows enterprise to move from experimentation to impact safely, reliably, and at scale. Let me move on to the next slide. I want to make sure that I give some disclaimer. All the views and opinions shared in this presentation are my own perspective. They don't represent or reflect the views of Amazon or AWS. I'm just sharing this purely out of my passion for MLOps and AI. All right. I want to start with a simple idea. A model in a Jupyter notebook is an experiment. A model in production, monitored and governed at scale, is a business solution. Think about how critical this is. At companies like Amazon, Netflix, or major banks, machine learning systems drive billions of decisions, recommendations, fraud detection, supply chain optimization, or even workforce planning. If these models fail, the business feels it very instantly. Now, we're also entering the era of large language models. They're powerful, but they're also unpredictable. ML ops is what keeps these systems reliable and trustworthy. My goal today is to show how automation, CICD, monitoring, and governance ensure just that. Let's talk a little bit on the challenges. Traditional ML projects often fail because pipelines are brittle. Maybe a column name changes in the source data and suddenly the feature store breaks. Deployments are often manual. Someone copies a model file, pushes it into production, and then sprays it works. And then there is monitoring, or rather, the lack of it. Many enterprises have models running in production right now that haven't been retrained in months or even years. That's a big problem. Let me give an example. A credit risk model at a financial firm that was trained on pre 2020 data. When COVID hit, consumer behavior changed overnight. Job losses, loan defaults, government relief checks, and so on. But the model wasn't monitored, and for months it misclassified risk, leading to massive financial losses. Now brings in LLM. Now let's bring in the LLM. They add even bigger risk, cost explosion, hallucination, and compliance gaps. So if ML ops was important before, in LLM world, it's absolutely mission critical. All right. Let's begin with what is ML ops. ML ops is about taking the best of DevOps, continuous integration, continuous delivery, infrastructure automation, and applying it to machine learning. But there's one more. DevOps deals with code, while MLOps deals with code, data, and models. Let's break it down. Data pipelines feed features into the model. The model itself is trained, validated, and versioned. Deployment must be automated across environments, and monitoring keeps track of the model performance over time. And now, with large language models, we need to extend this thinking to what some call LLM ops, where we manage not just training and deployment, but also prompt pipelines, retrieval augmentation, and fine tuning. The principles remains the same: automate, monitor, and govern. I want to talk about ML ops in the large language model era. As we shift now into the age of large language model, some people ask, Do we still need MLOps? And I think the answer is em- is a big yes. If anything, we need it even more. Why? Because the complexity of operating large language model is even higher than classical machine learning. Just like we manage feature pipelines for machine learning, in large language we now manage prompt pipelines. Prompts evolve, chains of prompts need testing, and they must be version controlled. Fine tuning in large language model is very expensive. Without automated evaluation pipeline, you risk wasting millions retraining models unnecessarily. Monitoring also becomes broader. We don't just watch accuracy or latency, we track hallucination, toxicity, bias, and grounding. For example, a large language model chatbot in healthcare starts producing advice not grounded in medical solutions. We need guardrails to catch that instantly. Finally, governance. With machine learning, we tracked data sets and model versions. With LLM, we must also track data compliance and human feedback loops. MLOps gives us the foundation to make LLMs reliable, responsible, and scalable in enterprise context. Without it, large language model adoption will stall because enterprise won't trust them in mission critical use cases. Let's move on to MLOps lifecycle. The MLF lifecycle looks like a loop, not a straight line. It begins with data ingesting and pre-processing, validating data, detecting schema changes, applying feature engineering, and so on. Then comes model training and fine tuning, often tracked in ML Flow or SageMaker with hyperparameters and metrics. Next is validation. This isn't just accuracy, it's fairness, robustness, and interpretability. Then comes deployment. This could mean exposing an API, containerizing in model, or serving it via feature store. Finally, monitoring and feedback loop closes the entire cycle. We monitor accuracy, drift, and latency. If something falls out of the bounds, retraining triggers automatically. A real world example, a retail store recommendation models retrain daily with new browsing and purchase data. They are validated against test sets, rolled out with shadow deployments, and monitored for drift. For large language models, this lifecycle also includes prompt, chain testing, ground checks, and human in the loop review to ensure the output remains useful and safe. All right. Automation. I think automation is the first pillar. Without it, a machine learning model becomes artisanal, slow, inconsistent, and fragile. Take a retail company running pricing optimization. If a data engineer has to manually rerun the pre processing scripts every time new sales data arrives, they'll never keep up with the changing market condition. By automating the pipelines with Airflow or Kubeflow, retraining happens daily and reproducibly. For LLMs, automatic automation is equally crucial, as I've mentioned before. Imagine a chatbot trained on enterprise documentation. Automation ensures that when new docs are published, the retrieval index is refreshed, prompts are validated, and evaluation tests are triggered. No one has to manually intervene. Automation ensures that models are not one off science experiments, they're living systems. CICD for ML and large language models. CICD bring agility and discipline. In machine learning, we version not just code but data sets and models. Tools like DVC or ML Flow make this possible. Every new dataset goes through regression test, bias test, and unit test for features. Example, let's say at Netflix, thousands of models are deployed using CI/CD pipelines. If one experiment fails, it can be rolled back instantly. For large language models, CI/CD includes prompt versioning. Say you have a customer service chatbot, each new prompts template gets tested against historical customer interaction. Shadow deployment let you compare the new version against the old before fully rolling it out. And just like microservices, rollback strategies are essential because the cost of a bad model or prompt in production can be huge. Moving on to governance and responsible AI. Governance is all about trust and compliance. Enterprise needs to answer which model made this decision. What data was it trained on? Can we prove it wasn't biased? In financial services, regulators may demand proof of why a loan was denied. With ML ops governance, you can show the data set, the model version, and even the code used. LLMs take this a little bit further. We must track data where training or fine tuning data came from, red teaming results, what failure modes were tested, and regulatory compliances like GDPR, EU AI Act are very explicit about AI transparency. Responsible AI is not optional, it's the price of doing business with AI. Model and LLM training. So, monitoring is where the battle is won or lost. For classical ML, we monitor accuracy, latency, drift, and infrastructure cost. For example, a fraud detection at a bank looked great at launch, but started missing new fraud patterns after 6 months. Continuous monitoring detected drift early and triggered retraining, saving millions. LM introduced another monitoring challenge, the hallucination rate, the toxicity, grounding. Our answers tied back to real data sources. Some enterprises now run red teaming in production, monitoring outputs for unsafe responses and automatically flagging them for human review. Without monitoring, large language model can quickly become liabilities. I want to talk about some of the best practices in the large language model era. So, what works well? Use infrastructure as a code. So, every environment is reproducible. Adopt feature stores for ML and emerging prompt stores for LLMs. Automate bias testing, fairness checks, and safety evaluation as part of CICD. Build cross functional teams because reliable AI requires not just data scientists but engineers, compliance officers, and business leaders. Moving on to my final slide. This is just my closing and call to action. To close, let me emphasize this: MLOps is not outdated, it is evolving. It is the foundation that allows enterprise to scale both classical machine learning and modern large language models responsibly. Without automation, CI/CD, monitoring, and governance, models will or fail silently, cost too much, and expose you to regulatory risk. With them, AI becomes reliable, trustworthy, and scalable. So, whether you're deploying a custom churn model, a recommendation engine, or a generative AI assistant, remember ML Ops is the bridge between innovation and trust. With that, I want to thank everyone for taking the time to listen into my talk, and thank you very much.